Hello and welcome to the first Res Extensa devlog. Today we're going to be replacing a particular mechanic that I already had implemented, but which some testers have had trouble with. So at this point, you get this laser here, and you can't get past it. It damages you, and you can't go past. So the idea is that you play a bit of a lights out game. Each of these switches will activate the laser that it's connected to, as well as the two lasers beside it. But that has been a problem for some testers. They instead of doing the puzzle as I intended, they will instead try to get past it by doing something like this and just walking past. Now, this doesn't solve the puzzle, because as you can see, the power cable which you're trying to activate at this point is not active, and this elevator doesn't work. You have to activate both power cables for the elevator to work. But it is kind of reasonable that people would think that's what you should have to do in order to pass this puzzle. And what I just did is what you actually have to do. You have to turn all three off, and there's another step, but I won't be getting to that in this step log. But so I figured, to make it a little bit more clear on what you have to do, I should make it so there's just one laser that's being kind of fed by three other smaller lasers. So you got three small lasers that are up in the wall, and they're each activated and deactivated by switches. But until all three of those smaller lasers are deactivated, the one big central laser will stay activated, and that should make it more clear that you have to deactivate all of them. So that's what I'm going to be doing. And here we are looking at the room in the game engine. Now, this is the Godot engine version 3, which is a bit outdated. If you're starting a new project now, and if you have any sense at all, then you'll be using Godot version 4. But version 3 was the version that was available when I started this project, and if I moved it to version 4, I have to rewrite huge portions of it, so I'm stuck with the old version until this game is finished. Hopefully it'll be successful enough that I'll be able to work on another game and use the new version of the engine for that. But for now, the main reason why I'm in the engine looking at this is I want to just check to see how wide this whole assembly is. So it looks to be 1, 2, 3, 4, 5 tiles wide, and each tile is 64 pixels, so the whole replacement laser is going to have to be about 320 pixels wide, if my math is right. And if it's not, I'll be correcting it in the next clip. And here we are in Inkscape, which is a free open source vector art program that I use to make most of the 2D assets in this game. So now we have to set up our page to get it the way we want it. We want it in pixels, and now, as we've established before, this will be 320 pixels wide in game, but I like to make my assets at 4 times scale. That way, if I need to zoom in on them, I can, or if someone's playing this in a higher resolution, it'll still work, though I haven't really tested this game in any resolution higher than 1920 by 1080. But so 4 times 320 is 1280, and for the height, I'm not exactly sure how tall this is going to end up being, but let's give it 1280 again. Just that should be a safe amount. Now, the problem with making these things at a larger scale is if you scale a vector image down and it has straight lines going up and down that don't line up, that don't end up on an actual pixel line, once you've scaled it down, it just becomes a blurry mess. So in order to make sure that happens, I'm going to create a grid, and I'm going to have it at 4 pixels X and Y, which it is already set to. So yeah, now we should be set up to start the image. So let's get going. And ta-da! Of course, this doesn't look like much at the moment, but it has the essential components in place. It's got our light up emitter here. It's got a window here, which will let the background come through, which will allow me to put an animation for the actual lasers combining in this little window. And it's got a circular top section so that when I add the actual sublasers to this, I can put them at any angle I want to, and as long as they're the right length, they'll meet up with the outline properly, which is important because I want to be able to use this for more than just the 3 laser setup that I'm going to have in that room I showed earlier. I want to be able to use this elsewhere in the game. And speaking of which, because I want to use this elsewhere in the game, that is why it doesn't look like much right now, because there is no detail on it. And I don't want to make my line work too complicated, so I'm going to be adding the detail with shading. But I could just shade it all manually. I could just add highlights and shadows like you normally would, but I want to make this work at different angles. If maybe I'll want to put one in the floor. Maybe I'll want to put one in a wall. And I want to make sure that it works in any circumstance and still looks good. So instead of shading it manually, I am going to shade it using a normal map. Now, a normal map is an image where each pixel, the color of each pixel, represents the direction that that pixel is facing. And I've already got code in my game that will take those normal maps and detect where they're facing, and I can input a light source and it will detect if that light source is facing towards that pixel or away from that pixel or any combination, any place in between, and from that it will determine how much light it will be getting, and the shading can be done that way. And to create that normal map, first, we're going to create a height map, and a height map is a black and white image where the lightness of each pixel represents how high that pixel is. So that's what we're going to do next. And now we've got our height map. It was made using mostly gradient and blur tools. So I still don't really know what this is going to look like in the actual game, but let's take it into GIMP and convert this into a normal map. And now we've got it exported from Inkscape and imported into GIMP. Although I am seeing a little bit of a problem here. I use 2 different methods to do the gradient on these 2 sections of the image, so I am going to have to use the blur tool and fix that a little bit. Let's see if we can get this done without damaging things too much. All right, that should be all right. And let's go over to the other side and do it there. Okay, yeah, that should be all right. So now let's get this converted into a normal map. So in order to do that, it is just a built-in filter in GIMP. So I go to Filters, to Generic, and Normal Map. And the default settings are a bit too shallow. There isn't too much of a difference between the different directions. So I'm going to go to one of my presets here, and no, that's too much. 40, that should be enough. So the scale is all that's changed between these presets. So I'm going to hit OK, and that will create the normal map. And then we'll be able to get this imported into the game engine and see how it looks. And here it is in the game engine. I exported 3 different versions of the base image, one in light colors, one in medium colors, and one in dark colors, and combined them with the normal map that we just created and the code that I created earlier. And now we have a version of our main body that has shading applied, and no matter how I rotate it, the shading will always make sense. It'll update the direction that the light is coming from depending on which direction the image is facing. Now, I won't go into too much detail on how this works because a lot of this is custom code that I wrote, and the reason why I wrote it is because I'm using Godot 3. And Godot 3 was limited in how it could handle 2D normal maps, And I believe a lot of those limitations aren't a thing anymore in Godot 4. So a lot of what I had to do to get this working is just done automatically in the new version of the engine. So if you're going to be making a project with that engine, then a lot of this should just be taken care of for you, although you are going to have to look up how to do it yourself, because I've never really familiarized myself with that. But anyway, now we've got the main body of the laser emitter completed. So let's add the sub emitters and see how that all combines together. And now we've got the sub emitter drawn. As you can see, it only has an outline along the top portion. That's because when I overlay it over the main body of this whole assembly, I want it to appear as if it's all one unit rather than a main body with an extra doohickey on top. So, if we actually enable the main body, we can see that it actually does that. So that's should look all right in the actual game. It's also got these windows here where the actual laser will shine through, and it's got a height map that will sort of correspond with the height map on the main body. I've changed this arc from a groove to sort of an outcropping, and I've set the sub body, the height map on it to sort of hug these features of the main body. So let's see what that looks like in the game. And the sub laser is imported into the engine. I think it does a pretty decent job of looking like it's part of the same machine as the main unit underneath it. And I have set an offset on it so that its pivot point is down here. That way, when I rotate it, it stays in place and looks like it's still in a sensible position relative to the main unit. And the lighting, of course, also updates because that's why we use the normal maps. So now that it's imported into the engine, the next step it will be to get it coded up and animated. And it's animated, and a good chunk of the code is done. Not all of it, there's still more to do, but a lot of it is done now, and you can see the results. We get the three lasers joined together into one main emitter. I can also vary the number of lasers that there will be on this. There's no animation between them because this will just be a level design setting. And I did get a little bit lazy in the sub emitters in that I decided, what if these windows were made of frosted glass instead of clear glass? So that way I only need to show the light coming through instead of actually having to animate the laser. I've got the laser animated in this window here, which I think gets the point across. And I might decide to add an animated laser to these sub lasers eventually, but for now I think that works all right. And I've also added the ability to change the length of these sub lasers. That way I can make these in a little bit more of a straight line because the switches are going to be in a straight line. So I wanted this to correspond at least roughly to how the switches were set up to give the player a better idea of how they correspond to the sub emitters on the laser. And hopefully that will get the point across a little bit better. But yeah, so the next step will be to get it into the game itself and to finish coding up all the additional logic to get the lasers to activate and deactivate and have that affect the main emitter. And so that will be the next thing that you're going to see. And the new device is now implemented into the game. I've added a new object to act as a receiver for the beam, and the beam itself behaves more or less like the old ones did. It'll stop me as I try to pass, except now it'll vary in size depending on how many of these switches that I have active. Just demonstrate that here. And let me turn the whole thing off, which lets me pass through freely. The room itself is about the same as it was before, with the old lasers swapped out for the new one, and it doesn't look as cohesive as it could be, but I can tweak that as the game moves closer to completion. You should be able to see a more complete version of this room when my demo is available, which I hope will be soon. I'll be announcing on this channel when it is, so you can subscribe to keep updated, or you can follow my feed on Mastodon. You can also wishlist Res Extensa on Steam using the link in the description. I'm glad I was able to show you some of what I'm working on, and I hope to do more of these as I bring Res Extensa closer to completion. I'll see you then.